Hello everyone, my name is Ronak Adhikari and today we're going to talk about sequence and series. In this session, we're going to learn thoroughly about sequence and its types, series and its types, and finally, progression and its types. Sequence. A sequence is a list of items or objects which have been arranged in a sequential way. A sequence is either finite or infinite. An example of finite sequence is 1, 2, 3, 4, 5, and an example of infinite sequence is 1, 2, 3, 4, dot. There are three types of sequences. There are arithmetic sequence, geometric sequence, and harmonic sequence. A sequence obtained by adding or subtracting definite number to a preceding number is called arithmetic sequence, and a sequence obtained by multiplying or dividing definite number to a preceding number is called geometric sequence. And finally, a series of number is said to be harmonic sequence if the reciprocals of all the elements of the sequence form an arithmetic sequence. Series. A series is defined as the sum of elements of the sequence. For example, if A1, A2, A3 is an example of a sequence, then the expression A1 plus A2 plus A3 plus A4 is called series. There are three types of series. There are arithmetic series, geometric series, and harmonic series. An arithmetic series is the sum of the terms of an arithmetic sequence with a definite number of terms. Similarly, geometric and harmonic series are the sum of terms in geometric and harmonic sequence. Progression. A progression is a list of numbers or items that exhibit a particular pattern. In this lecture, we'll discuss briefly about two types of progression. There are arithmetic progression and geometric progression. Arithmetic progression. An arithmetic progression is a sequence of numbers in which each successive term is obtained by adding a preceding term with a fixed number. So in the given series 2, 5, 8, 11, 5 is obtained by adding 2 and a fixed number 3. Similarly, 8 is obtained by adding 5 and a fixed number 3. So the sequence 2, 5, 8, 11 is an arithmetic progression. In an arithmetic progression, the difference between the consecutive terms is also constant. So the difference between 5 and 2 is equals to 3. Similarly, the difference between 8 and 5 is also equals to 3. When we plot a graph of the certain term against the value of the progression at that value, we get a straight line. So in the given graph, y is equal to 3x plus 1 represents an arithmetic progression. Now we're going to learn about formulas used to determine the value of nth term, which is denoted by dn, and sum of n terms, which is denoted by sn in an arithmetic progression. To determine the values of n term and sum of n terms, you need to know the first term, which is denoted by a, and the common difference, which is denoted by d. Now the n term is given by a plus n minus 1d, and the sum of n terms is given by n by 2, 2a plus n minus 1d, and on simplification we get n by 2 a plus 1. Geometric progression. A sequence in which the ratio of two consecutive terms is constant is called geometric progression. The constant ratio is called common ratio and is denoted by r. So let us suppose a series 3, 6, 12, 24. Now the ratio of two consecutive terms 6 is to 3 equals to 2, and similarly the ratio of two consecutive terms 12 by 6 equals to 2. So this series is in geometric progression. In this given series, 2 is the common ratio. If we plot a graph of geometric function, we get an exponential function. So in the given graph, the equation y equals to 3 into 2 to the power x represents the series 3, 6, 12, which is in geometric progression. And the given graph is an exponential graph. Now we're going to learn about formulas used to determine the nth term, which is denoted by dn, and sum of n terms denoted by sn in a geometric progression. To determine the values of n term and sum of n terms, you need to know the value of first term denoted by a and common ratio denoted by r. Now the n term is given by a into r to the power n minus 1, and sn is given by a times 1 minus r to the power n divided by 1 minus r if common ratio is greater than 1, or a by 1 minus r if common ratio is less than 1.